2,000 years ago, Roman builders created something that modern engineers are still trying to understand. Their roads, harbors, aqueducts, and massive structures survived centuries of rain, earthquakes, and even the relentless power of the sea. One of the most famous examples is the Pantheon in Rome, whose enormous unreinforced concrete dome has survived for almost 2,000 years. Inside many ancient Roman concrete samples were tiny white fragments called lime clasts. For years, they were researchers now believe the Romans may have used a technique called hot mixing, using highly reactive quicklime that generated intense heat when water was added. When water reaches these lime clasts, calcium can dissolve into the water and move through the crack, where new minerals can begin to fill the opening. In the right conditions, those minerals can gradually seal parts of the crack, giving the ancient concrete a remarkable ability to repair itself. To test the theory, researchers recreated Roman concrete and deliberately fractured the samples, then watched what happened when water entered the cracks. When researchers exposed the cracked material to flowing water, the water initially passed through.
But did Roman builders actually use this hot mixing process? Pompeii may have preserved an extraordinary clue.
What exactly did archaeologists find?
At a construction site preserved by the eruption of Mount Vesuvius, researchers found materials that had remained remarkably close to their original state. The Roman recipe combined lime, volcanic ash, and aggregate, but the way these ingredients were mixed may have made all the difference.
When water reacts with quicklime, it releases intense heat, creating the unusual conditions that may have shaped the concrete from the very beginning.
The intense mixing process could leave behind tiny pockets of reactive lime inside the concrete, what scientists now call lime clasts.
And centuries later, those reactive lime clasts could still remain inside the concrete, waiting for water to reach them.
The Romans probably didn't understand the chemistry the way modern scientists do, but through generations of experience, they learned how to build and what materials worked.
Today, scientists aren't simply trying to copy Roman concrete. They're studying its principles and asking whether ancient ideas could help us build materials that last longer.
If scientists can learn from these ancient principles, future concrete could potentially become more durable, reducing repairs and helping structures last longer.
The Romans may not have understood the chemistry behind their concrete, but their buildings survived long enough to teach that chemistry to us.
2,000 years later, Roman concrete is still standing and still teaching us how to build.